This is Musanjarayan Group 3, Luagade. I'm going to discuss questions 23, 28, and 41. Now, starting off with 23 is in the subtopic of classification and prediction. The first question is describe how neural networks, particularly the deep learning models, are applied in classification tasks. Neural networks are widely used in classification tasks, and here's a general overview how they are applied. Number one is data preparation. You have to start with a labeled data set where each data point is associated with a class or category. The data set is divided into training, validation, and test sets. The next task is network architecture. Choose a neural network architecture suitable for your classification task. Convolutional neural networks are often used for image classification, while recurrent neural networks or transformer models might be suitable for text classification. Input encoding. Preprocess the input data and convert it into a format suitable for the neural network. For images, this might involve resizing and normalization. For text, it involves tokenization and word embedding. Model training. Train the neural network using the training data, which involves adjusting the model's parameters, that is the weights and biases, to minimize the loss function, which measures the difference between the predicted and the actual labels. Common optimization algorithms include stochastic gradient descent and variants like Adam. Also, you have hyperparameter tuning. You have to experiment with hyperparameters like lining rate, batch size, and architecture choices to optimize the model's performance. Cross-validation and grid search can help with finding the best hyperparameters. Another task is validation. Use the validation set to monitor the model's performance during training. This helps prevent overfitting, where the model becomes too specialized to the training data. Testing. Assess the model's performance on the test set to evaluate its generalization capabilities. Common metrics for classification tasks include accuracy, include accuracy and common metrics for classification tasks include accuracy and precision, recall, F1 score, and confusion matrices. Post-processing. Depending on the specific application, you might need to post-process the model's outputs. For example, in natural language processing tasks, you may apply a softmax function to get class probabilities. Deployment. Once the model performs well, it can be deployed for real-world use. This could involve integrating it into a mobile app, a website, or any other software system. Monitoring and maintenance. Continuous monitoring and periodic retraining may be necessary to ensure that the model remains effective over time, especially if the data distribution changes. In conclusion, neural networks offer great flexibility and can handle a wide range of classification tasks from image and speech recognition to sentiment analysis and more. The specific steps may vary depending on the problem and the data at hand. So the next question in that subheader is what are their advantages and challenges? Neural networks are a fundamental component of deep learning and have several advantages and challenges. Now, going on with the advantages, we have they help to learn complex patterns. Neural networks can learn intricate patterns and relationships with data, making them suitable for tasks like image recognition and natural language processing. Flexibility, they can be applied to a wide range of problems from image and speech recognition to recommendation systems and autonomous driving. Feature learning, neural networks can automatically learn relevant features from the data, the need reducing the need for manual feature engineering. Scalability is another advantage, as deep neural networks can scale with more data and computing power, potentially improving their performance. transfer learning. Retrained neural networks can be fine-tuned for specific tasks, saving time and resources. Now, going on to their challenges, we have data dependence. Neural networks tend to require large amounts of data for training and performance, hence may suffer with insufficient or biased data. Complexity. Deep neural networks can be difficult to design and train with numerous hyperparameters to tune. Computational resources. Training deep neural networks often demands significant computational resources, including GPUs or TPUs. Overfitting. Neural networks tend to overfit the training data, resulting in poor generalization to new unseen data. Interpretability. Understanding the inner workings of deep neural networks can be challenging, which is a concern for critical applications like healthcare and finance. Then going on to the ethical concerns, there are ethical considerations related to the use of neural networks, including bias in AI systems and also with privacy issues. Adversarial attacks. Neural networks can be vulnerable to adversarial attacks, where subtle modifications to input data can cause misclassification. Training time. Training deep networks can be time consuming, limiting their real time applicability in certain domains. In summary, while neural networks have revolutionized the AI space, they come with both advantages and challenges that researchers and practitioners need to consider when applying them to various tasks. So going on to the second question, in the question 23, we have what is the cause of dimensionality? The cause of the dimensionality refers to the problems and the challenges that arise when working with high dimensional data. As the number of features or dimensions in a dataset increase, various issues occur. How, do, how does it affect classification models? Cause of dimensionality affects the classification models in the following ways. There's increased computational complexity. Processing and analyzing high dimensional data becomes computationally expensive as the number of calculations and memory requirements grow exponentially. The sparsity of data. In high dimensional spaces, data points tend to become sparse, making it challenging to find meaningful patterns or relationships. High dimensional data also increases the risk of overfitting in machine language models, where models may perform well on the training data but poorly on new unseen data. Difficulty in visualization. Visualizing data in high dimensional spaces is complex, as humans can only easily comprehend two-dimension or three-dimensional representations. Diminished distance measures. Intuitively meaningful distance measures lose their effectiveness in high dimensions, making it harder to identify similar data points. To mitigate the cause of dimensionality, techniques like feature selection, dimensionality reduction, and regularization are often used in data analysis and machine learning to extract relevant information from high dimensional datasets. Question C. Discuss the challenges and the ethical considerations to be considered when dealing with sensitive attributes in classification like race or gender. Dealing with sensitive attributes like race or gender in classification tasks presents several challenges and ethical considerations. As seen below, bias and fairness. One of the primary concerns is the potential for bias in the data and the model's predictions. Biased data can lead to unfair or discriminatory outcomes, reinforcing existing society inequalities. Privacy concerns. Using sensitive attributes can risk violating an individual's privacy, as these attributes can reveal personal information about them. Transparency. It can be Discuss the challenges and ethical considerations when dealing with sensitive attributes in classification. I talked of also transparency, as it can be challenging to explain how a model based on sensitive attributes, which may hinder transparency and accountability. Fairness metrics. Defining and measuring fairness is complex. Choosing the right fairness metric and understanding its implications is very crucial. Data collection, collecting and handling data on sensitive attributes can be ethically challenging. It's important to obtain informed consent and anonymize data approximately. Unintended consequences. Mitigating bias by removing sensitive attributes can lead to other unintended biases or fairness issues in the model. Stakeholder involvement. Ensuring that stakeholders, especially those directly affected by the model's predictions, have a say in its development and deployment is vital. Regulatory compliance. Ethical considerations also encompass adhering to relevant regulations such as GDPR in Europe, which has stringent rules about handling personal data. Algorithmic accountability. It's important to establish processes for auditing and addressing any biases or unfair outcomes that may arise from using sensitive attributes. Continuous monitoring and evaluation. Regularly monitoring model performance and assessing its fairness is essential to detect and rectify biases over time. To address these challenges and ethical considerations, organizations should adopt responsible AI practices, including bias mitigation techniques, fairness aware machine learning, and transparent model documentation. They should also engage with experts, stakeholders, and affected communities to make informed decisions. The next sub question is, what are the implications of imprecision and uncertainty in classification models? Imprecision and uncertainty in classification models can have several implications. Misclassification. Imprecision can lead to misclassification of data points, where instances are assigned to the wrong class, potentially causing errors or misinformation. Reduced confidence. Uncertainty in predictions can result in reduced confidence in model outputs, making it challenging to make decisions based on model results. Ethical concerns. Misclassifications can have ethical implications, especially in sensitive domains like healthcare or criminal justice, where incorrect predictions can lead to serious consequences. Model interpretability. Uncertainty can make it more challenging to interpret the model's decisions, as it becomes less clear why a particular prediction was made. These are ways to manage imprecision and uncertainty in classification models. One is improve data quality. Ensure that the data used for training and testing is clean, accurate, and representative of the problem domain. High quality data can reduce imprecision. Feature engineering. Carefully engineer features that are informative and relevant, which can help the model make more precise predictions. Ensemble methods. Use ensemble methods like random forests or gradient boosting, which combine multiple models to improve prediction accuracy and reduce uncertainty. Calibration. Calibrate model probabilities to reflect the true likelihood of a data point belonging to a particular class. This can help in managing uncertainty. Threshold adjustment. Adjust the classification threshold to control the trade-off between precision and recall, depending on the specific needs of your application. Cross-validation. Employ cross-validation techniques to assess model performance and identify the source of uncertainty and imprecision. Bayesian models. Bayesian models can explicitly model uncertainty and are useful in situations where quantifying uncertainty is essential. Uncertainty estimation. Some models like Bayesian neural networks can estimate uncertainty for each prediction, providing a measure of confidence in the results. Post-processing. Apply post-processing techniques such as smoothing or filtering to the model's output to reduce uncertainty. Feedback loops, continuously updating and improving the model based on feedback from real-world performance, can also help improve on this precision. In summary, managing imprecision and uncertainty in classification models requires a combination of data reprocessing, model selection, calibration, and ongoing monitoring and improvement to ensure that the model's predictions are as accurate and reliable as possible. The next subheader is how can you handle missing data when building a classification model. Handling missing data is crucial when building a classification model. Here are some common approaches. Data imputation. Fill in missing values with estimated or calculated values. Common imputation techniques include mean, median, model imputation for numerical features, and using the most frequent category for categorical features. Deletion. Remove rows or columns with missing data. This is a simple approach but can result in loss of valuable information. Use it when missing data is negligible. Predictive imputation for missing values. You can train a separate model to predict missing values based on other features. For instance, you can use regression for numerical data or another classification model. Another classification model for categorical data. For time series data, you can use interpolation methods to estimate missing values based on neighboring data points. Flagging. Introduce an indicator variable or in brackets a flag that denotes whether a value is missing. This way the model can learn from the absence of data. Multiple imputations. Use advanced techniques like multiple imputations to increase multiple datasets with imputed values and then combine the results for more robust predictions. Domain specific handling. Sometimes domain knowledge can guide the handling of missing data. For example, in a medical dataset, missing values for a blood type might be assumed to be a separate category. In simple methods, when using tree-based methods, e.g. random forests or XGBoost, they can naturally handle missing data. The model splits data based on available features, so missing values are treated implicitly. Feature engineering. Create new features that indicate the presence or the absence of missing values in other features. This can help the model capture patterns related to missing data. The choice of method depends on the nature of your data, the extent of missing data, and the goals of your classification model. It's also essential to assess the impact of your chosen method on the model's performance through validation and other evaluation techniques. Moving on to the next question, with question 28. It's all about text and web mining. What is text mining? Text mining, also known as text analytics, is the process of extracting valuable information and insights from unstructured text data. It involves analyzing and transforming large volumes of text, such as documents, articles, social media posts, and more, into structured data that can be used for various purposes. Text mining techniques include natural language processing, which enables tasks like sentiment analysis, topic modeling, named entity recognition, and text classification. Text mining is widely used in fields like data analysis, information retrieval, and machine learning to uncover patterns, trends, and knowledge from textual data. What is the difference between text mining and data mining? Text mining and data mining are both techniques used for extracting valuable information, but they focus on different types of data and have different purposes. Text mining. Text mining. Text mining. Eh, text mining. Text mining deals with unstructured textual data such as documents, emails, social media posts, and more. It aims to extract insights and knowledge from natural language text. Techniques in text mining include natural language processing for tasks like sentiment analysis, topic modeling, and text classifications. It is commonly used in applications like sentiment analysis, content recommendation, and document summarization. Data mining. Data mining involves structured or semi-structured data, typically stored in databases or spreadsheets. It aims to discover patterns, correlations, and trends in numerical or categorical data. Techniques in data mining include clustering, regression, and decision trees. Data mining is often used for tasks like customer segmentation, fraud detection, and predictive modeling. In summary, text mining focuses on extracting information from unstructured textual data, while data mining deals with structured or semi structured data to uncover patterns and relationships. They are both valuable tools in the field of data analysis but are applied to different types of data and tasks. Explain the key steps in the text mining process. Explain the key steps in the text mining process. Text mining is the process of extracting valuable information and insights from unstructured text data. Here are the key steps in the text mining process. Data collection. You have to gather the text data from various sources like documents, websites, social media, or other text-based content. Pre-processing. Text cleaning. Pre-processing involves text cleaning. You have to remove irrelevant characters, symbols, and formatting to ensure that the text is in a consistent format. Tokenization, you have to break the text into individual words or tokens. Stop word removal. Eliminate common non-informative words like the, and, or in. Stemming or lemmatization. Lemmatization. You have to reduce words to their root form to handle variations. Text understanding. Text understanding involves text parsing. You have to analyze the structure of the text to identify sentences, paragraphs, and sections. Named entity recognition. Identify entities like the names, the dates, and the locations. Part of speech tagging. Assign grammatical tags to words to understand their role in the text. Feature extraction. Convert the text into numerical or categorical features that can be used for analysis. Techniques like term frequency, inverse document frequency, or word embeddings like word to vec can be applied. Text analysis. Sentiment analysis. Text analysis involves sentiment analysis. You have to determine the sentiment or the emotional tone of the text. Topic modeling. Discover the underlying themes or topics within the text using methods like latent Dirichlet allocation or LDN brackets. Text classification. Categorize documents into predefined classes or labels using machine learning algorithms. Text visualization. Create visual representations of the text data to aid in understanding and interpretation, such as word clouds or network diagrams. Model building. Develop machine learning or natural language processing models to perform tasks like document classification, text summarization, or information retrieval. Evaluation. Assess the performance of text mining models using appropriate metrics like accuracy, precision, recall, or F1 score, depending on the specific task. Interpretation and insights. Analyze the results to extract meaningful insights from the text data. which can inform decision making, trend analysis, or other applications. Deployment. Implement the text mining process in a real world context, such as for automating customer support, information retrieval, or any domain specific use case. These steps may vary depending on the specific objectives of the text mining project and the tools as well as the techniques used. How do you convert unstructured text data into structured information? Converting unstructured text data into structured information involves several steps as seen below. Text, text preprocessing. Clean and prepare the text data by removing special characters, punctuation, and irrelevant information. Tokenize the text into words or phrases. Named entity recognition. Identify and extract named entities like names, dates, location, and organization from the text. Part of speech tagging. Assign grammatical tags to words to understand their roles in sentences, such as nouns, verbs, and adjectives. Text classification. Categorize the text into predefined categories or topics using machine learning algorithms or rules-based approaches. Sentiment analysis. Determine the sentiment or the emotion expressed in the text, whether be it positive, negative, or neutral. Natural language processing techniques. Utilize NLP libraries and models to perform tasks like text summarization, topic modeling, and document clustering. Information extraction. Extract structured data from the text like key facts, dates, and events. Entity resolution. Resolve entities to unique identifiers to create a database of related information. Data structuring. Organize the extracted information into a structured format like database spreadsheet or JSON for easy retrieval and analysis. Validation and quality control. Ensure the accuracy and consistency of the structured data by validating it against known sources or using automated quality control measures. Data integration. Combine structured information from various sources to create a comprehensive dataset. Store the structured data in a suitable format or database for easy access and retrieval. These steps can be implemented using a combination of programming, NLP tools, and machine learning techniques to effectively convert unstructured text data into structured information. What are the common challenges in text mining, such as handling unstructured data and dealing with noisy text? Common language Common challenges in text mining include data preprocessing, cleaning and preparing text data for analysis, including tasks like removing stop words, stemming, and handling missing values. Ambiguity. Text often contains ambiguity, making it challenging to predetermine the intended meaning of words or phrases. Language variability. Different languages, dialects, and writing styles can complicate text mining. Scalability. Handling large volumes of text data efficiently is a significant challenge. Information extraction. Identifying and extracting relevant information from unstructured text can be complex. Text classification. Categorizing text into predefined categories or labels can be difficult, especially with imbalanced datasets. Sentiment analysis. Determining the sentiment, positive, negative, or neutral in text accurately is a challenge due to the sub subtleties of language. Named entity recognition. Identifying and classifying entities like names and places within text can be error prone. Machine learning models. Selecting the right algorithms and models for text mining tasks is a critical challenge. Interpreting results. Named entity recognition, identifying and classifying entities like names, places within text can be error prone. Machine learning models, selecting the right algorithms and models for text mining tasks is a critical challenge. Interpreting results, making sense of the insights and patterns extracted from text data can be subjective and complex. Handling noise, dealing with noisy or irrelevant information in text data can affect the quality of results. Privacy and ethics, ensuring that text mining respects privacy and ethical considerations, especially in sensitive domains. Domain specific challenges. Text mining may require domain specific knowledge to address unique challenges in various fields. Continuous learning, keeping up with evolving language, slang, and new terminology is essential for accurate text mining. Addressing these challenges often involves a combination of natural language processing techniques, machine language, and domain expertise. Discuss the applications of text mining in various domains, including sentiment analysis, information retrieval, and document classification. Here are some common applications of text mining. Sentiment analysis, analyzing social media posts, reviews, and customer feedback to determine public opinion about products, services, or brands. This information can be used for marketing and reputation management. Information retrieval, improving search engines by understanding the context of search queries and retrieving more relevant results. Text classification, categorizing documents or text into predefined categories like spam email detection, topic categorization, or news classification. Named entity recognition, identifying and extracting entities like the names of people, organizations, locations, and dates from text is useful in information extraction and indexing. Topic modeling, discovering hidden topics within a collection of documents, which can be used for content recommendation, organizing content, and summarization. Text summarization, automatically generating concise summaries of long documents is valuable in content curation and news aggregation. Language translation, machine translation services like Google Translate use text mining techniques to convert texts from one language to another. Information extraction, identifying specific information from text like extracting structured data from unstructured documents like invoices, contracts, and news articles. Customer support and chatbots, applying customer inquiries to provide automated responses and route inquiries to the appropriate support agents. Document clustering, grouping similar documents together with aids in organizing large document collections and enhancing such capacities. Market intelligence, analyzing new articles and financial reports to predict market trends and stock price movements. So is the plagiarism detection, identifying instances of content plagiarism, which is essential in academia and publishing. Healthcare informatics, analyzing electronic health records, medical literature, and clinical notes to aid in diagnosis, treatment recognition, and medical research. Fraud detection, detecting fraudulent activities by analyzing textual data, like identifying suspicious patterns in insurance claims or financial transactions. Public opinion and policy analysis, assessing public sentiment and analyzing political speeches and documents to inform policy making. Legal document review, reviewing legal documents for due diligence, contract analysis, and e-discovery in the legal field. Educational assessment, analyzing essays and written assignments for grading and providing feedback in educational settings. They're also used in competitive intelligence, analyzing texture data to gain insights into competitors' strategies and market positions. Text mining is a versatile technology with applications spanning across industries, hence enabling organizations to extract meaningful insights from the vast amount of unstructured textual data available today. Describe natural language processing and its role in text mining. Natural language processing is a branch of artificial intelligence that focuses on interaction between computers and human language. It enables computers to understand, interpret, and generate human language in a way that is valuable and meaningful. NLP plays a crucial role in text mining by providing the tools and techniques to extract valuable information from large volumes of unstructured text data. NLP techniques are essential in this process because they enable information extraction. NLP helps to extract relevant information from texts like key entities, events, and facts. Document categorization. Text can be categorized into predefined classes or topics, making it easier to organize and search for information. Sentiment analysis. Understanding public opinion and customer sentiments by analyzing textual data. NLP is also used in search and retrieval because they enable more advanced and accurate search and retrieval of information by understanding the context and the meaning of queries. Summarization. Automatically generating concise summaries of lengthy documents to facilitate quicker comprehension. Language translation. Converting text from one language to another is vital for international businesses and cross-cultural analysis. How does NLP help in understanding and processing human language? So NLP helps in understanding and processing human language in the following ways. One is text understanding. NLP algorithms can analyze and comprehend the meanings of text, allowing computers to extract information, identify entities, and discern sentiment. Speech recognition. NLP enables machines to convert spoken language into text that is valuable for applications like voice assistants and transcription services. Machine translation. NLP facilitates the translation of text from one language to another, improving cross-lingual communication. Sentiment analysis. They also help to determine the sentiment or emotional tone in text, making it useful for applications like social media monitoring and customer feedback analysis. Information retrieval. NLP helps to power search engines by understanding user queries and retrieving relevant documents from vast text databases. Text generation. NLP models can generate human-like text that is useful for chatbots, content generation, and creative writing. Text generation. NLP models can generate human-like text that is useful for chatbots, content generation, and creative writing. Text summarization. NLP algorithms can automatically summarize long documents, making it easier to extract key information from large amounts of text. Question answering. They also help in building question answering systems that can provide answers to user queries from a given text. Named entity recognition. NLP can identify and classify entities such as names of people, organizations, locations, and more in text. Syntax and grammar analysis. NLP can parse and analyze the grammatical structure of sentences, aiding in understanding sequence, meaning, and context. Language understanding in chatbots. It is also crucial for chatbots and virtual assistants to understand and respond to user queries in natural language. Text classification. NLP models can classify text into categories, which is used in spam detection. I'm in group 3 Robagade. So I'm going to discuss this first session. Number 23, the subtopic is classification and prediction. So we're going to describe how neural networks, particularly the deep learning models, are applied in classification tasks. Neural networks are widely used in classification tasks. Here's a general overview how they are applied. Data preparation. So start with a labeled data set where each data point is associated with a class or category. The data set is divided into training, validation, and test sets. Second step is setting up a network architecture. Here, the neural network architecture is chosen for a suitable classification task. Convolutional neural networks are often used for image classifications, while the recurrent neural networks or transformer models might be suitable for text classification. The next is input encoding. We have to preprocess the input data and convert it into a format suitable for the neural network. For images, this might involve resizing and normalization. For text, it often involves tokenization and embedding and word embedding. The other one, we have model training. You have to train the neural network how to use the training data. This involves adjusting the model's parameters such as weights and biases to minimize the loss function, which measures the difference between the predicted and actual labels. Common optimization algorithms include the SGD, stochastic gradient descent, and variants like Adam. Then we have the hyperparameter tuning. You have to experiment with hyperparameters like learning rates, batch size, and architecture choices to optimize the model's performance. Cross-validation and grid search can help find the best hyperparameters. The other step is validation. Use the validation set to monitor the model's performance during training. This helps to prevent overfitting, where the model becomes too specialized for the training data. Another step is testing. You have to assess the model's performance on the test set to evaluate its generalization capabilities. Common metrics for classification tasks include accuracy, precision, recall, the F1 score, and confusion matrices. Post-processing. Depending on the specific application, you might need to post-process the model's outputs. For example, in natural language processing tasks, you may apply a softmax function to get class probabilities. Then you have deployment. Once the model performs well, it can be deployed for real-world use. This could involve integrating it into a mobile app, a website, or any other software system. You have monitoring and maintenance. Continuous monitoring and periodic retraining may be necessary to ensure that the model remains effective over time, especially if the data distribution changes. In conclusion, neural networks offer great flexibility and can handle a wide range of classification tasks from image and speech recognition to sentiment analysis and more. The specific steps may vary depending on the problem and data at hand. The subsection to the first question is, what are their advantages and challenges? We're talking about the advantages and challenges of using neural networks. So neural networks are a fundamental component of deep learning and they have several advantages and challenges. Henceforth, the advantages we have, they help to learn complex patterns. Neural networks can learn intricate patterns and relationships within data, making them suitable for tasks like image recognition and natural language processing. Flexibility. They can be applied to a wide range of problems, from image and speech recognition to recommendation systems and autonomous driving. Feature learning. Neural networks can automatically learn relevant features from the data, reducing the need for manual feature engineering. Scalability. Deep neural networks can scale with more data and computing power, potentially improving their performance. Transfer learning. Pre-trained neural networks can be fine-tuned for specific tasks, saving the time and resources. Then challenges, data dependency. Neural networks require large amounts of data for training, and performance may suffer with insufficient or biased data. Complexity. Deep neural networks can be difficult to design and train with numerous but I was still struggling because now the noise. I was using the phone now. But can you pause? Okay. Just stop recording. Like, how will you join them? Just get set. Hello. I'm going to the last question, which is question 41. Ethical and privacy considerations. Principles of transparency and accountability. That transparency and accountability crucial principles in data mining to ensure responsible and ethical practices. You have informed consent. You have to obtain clear and informed consent from individuals before collecting and using their data. This data collection transparency is required as you have to clearly disclose the purpose of collecting the data and how will it be used. Also, you have data minimization. Only collect data that is necessary for the intended purpose to minimize intrusiveness. You have data security. You have to implement robust security measures to protect the data from unauthorized access or breaches. Also, have data quality. Ensure data accuracy and quality to prevent biased or misleading results. However, algorithm transparency. You have to make the data mining algorithms and models transparent and explainable to understand their decision-making processes. Accountability mechanism. Establish mechanisms for addressing issues, complaints, and accountability for data misuse. You have to make regular audits, conduct regular audits to assess compliance with ethical data mining practices. You should also portray fairness. You have to address bias and discrimination in data mining by ensuring fairness in the treatment of different groups. Privacy protection. Protect individuals' privacy by anonymizing or de-identifying data when necessary. Data retention limits. Specify how long data will be retained and when it will be deleted. Transparency reports. publish reports detailing data mining activities, outcomes, and their societal impacts. Adhering to these principles helps to build trust and ensure responsible data mining practices. How can organizations ensure that data mining practices are transparent and accountable to individuals whose data is being mined? To ensure transparency and accountability in data mining practices, organizations should consider the following steps. You have clear data usage policies. Develop clear and concise data usage policies that explain how data will be collected, stored, and used. These policies will easily be accessible to individuals whose data is being mined. How to make informed consent. Seek informed consent from individuals before collecting their data. This should involve providing information about their purpose of data collection and how will it be used. Data anonymizing. To anonymize or to pseudonymize data whenever possible to protect individuals' identities and their privacy. Also ensure data security. To implement strong data security measures to protect the data from breaches and unauthorized access. Data retention policies. Establish clear data retention and deletion policies to ensure that data is not retained longer than necessary. Data access requests. Allow individuals to request access to their own data and provide a means for them to correct or delete their data when necessary. Third-party audits. Periodically engage third-party auditors to assess data mining practices and ensure compliance with established policies. Ethical considerations. You have to consider ethical implications of data mining practices and integrate ethical principles in their decision-making processes. Education and training. Train employees and stakeholders about the importance of data privacy and ethical data mining practices. Regulatory compliance. Stay up to date with data protection laws and regulations such as GDPR, also CCPA, to ensure compliance with them. Transparency reports. Publish regular transparency reports that detail data mining activities, including the types of data collected, purposes, and any incidents or breaches. Accountability mechanisms. Implement accountability mechanisms that hold individuals responsible for data mining practices and establish a clear chain of responsibility. Data privacy officers. Appoint a data privacy officer to oversee and ensure compliance with data protection laws and best practices. Data subject rights. Ensure individuals have the right to request information about how their data is being used and to opt out of certain data mining activities. Feedback channels. Provide channels for individuals to provide feedback, raise concerns, or report issues related to data mining practices. Continuous improvement. Continuously assess and improve data mining practices in light of changing regulations and ethical standards. By following these guidelines and maintaining a commitment to transparency and accountability, organizations can build trust with individuals whose data is being mined and mitigate potential privacy and ethical concerns. How do privacy regulations impact data mining practices and ethical considerations? Privacy regulations have a privacy regulations have often require organizations to obtain explicit consent from individuals before collecting their data. This impacts data mining as it necessitates transparency in data collection practices, ensuring that individuals are aware of how their data will be used. Data minimization. Regulations like GDPR encourage the principle of data minimization, meaning that organizations should only collect and process data that is necessary for the intended purpose, hence affecting data mining by limiting the scope of data that can be used for analysis. Data anonymization. Privacy regulations often require the anonymization of data individual identities. Data mining practices must consider these requirements to ensure that personal information is adequately protected. Data security. Ethical data mining practices should include robust data security measures to protect the data from breaches. Privacy regulations may mandate specific security requirements, reinforcing the ethical obligation to safeguard sensitive info. Data portability and deletion. Some regulations like GDPR grant individuals the right to request their data and have it deleted. Data miners need to consider these rights and provide mechanisms for individuals to access and manage their data. Data portability and deletion. Some regulations like GDPR grant individuals the right to request their data and have it deleted. Data miners need to consider these rights and provide mechanisms for individuals to access and manage their data. Algorithm transparency. Privacy regulations may also impact the transparency of data mining algorithms. Individuals have the right to know how decisions affect them made. Ethical data mining practices involve explaining the workings of algorithms to maintain transparency. Bias and fairness. Regulations can encourage the ethical consideration of bias and fairness in data mining. It is essential to ensure that data mining practices do not lead to discriminatory or biased outcomes. Accountability. Privacy regulations often require organizations to be accountable. Accountability. Privacy regulations often require organizations to be accountable for their data processing activities. This includes maintaining records of data processing and conducting data protection impact assessments, which are ethical considerations for data mining. In summary, privacy regulations play a crucial role in shaping data mining practices and ethical considerations, promote transparency, data protection, and accountability, aligning with the ethical principles of respecting individuals' privacy and rights when using their data for analysis. In what ways can data mining algorithms introduce biases? Data mining algorithms can introduce biases in several ways. Bias training data. If the training data used to build these algorithms contains bias, for example, if historical data reflects social or economic biases, the algorithm may make biased predictions. Feature, feature selection. Data mining algorithms may prioritize certain features in the data over others, which can lead to biased results if these features are themselves biased or if relevant features are omitted. Model selection. The choice of a particular data mining model or algorithm can introduce bias. Some models may inherently favor certain types of data or assumptions, leading to biased outcomes. Sampling bias. If the data set used for training is not representative of the rural population, it can introduce sampling bias. For instance, undersampling or oversampling certain groups can lead to biased predictions. Algorithmic bias. The design of the algorithm itself can introduce bias, for example, using certain mathematical functions or heuristics that favor certain groups can result in biased outcomes. Evaluation metrics. The choice of evaluation metrics can influence the algorithm's behavior. If the metrics used do not account for fairness or bias, The algorithm may optimize for other objectives as express of fairness. Data reprocessing. Preprocessing steps like data cleaning, normalization, or imputation can inadvertently introduce or exacerbate biases if not done carefully. Lack of diversity in development. A lack of diversity among the teams developing and testing data mining algorithms can introduce cultural and cognitive biases into the algorithms and their decision-making processes. To mitigate these biases, it's essential to employ fairness, aware, and ethical AI practices. Thoroughly evaluate models for bias and use diverse and representative training data. Regular auditing, transparency, and ongoing monitoring of algorithm behavior are also critical steps in addressing biases in data mining algorithms. What are the ethical implications of biased results? What are the ethical implications of biased results? Biased results in data mining can have significant ethical implications, including discrimination. Biased data can lead to discriminatory outcomes, reinforcing existing inequalities in areas such as employment, housing, and finance. Unfair treatment. Biased results may unfairly treat certain individuals or groups, leading to unjust consequences. Privacy concerns. Biased data mining can infringe on individuals' privacy by revealing sensitive information and perpetuating data vulnerabilities. Trust and credibility. Biased results erode trust in data-driven decision-making and can have the credibility of data mining techniques. Social impact. Biased data mining can perpetuate stereotypes and divisions, affecting society's cohesion and inclusivity. Legal issues. Depending on the context, biased data mining can lead to legal challenges as seen in cases related to discriminatory lending practices. Addressing these ethical concerns involves ensuring diverse representative data, transparency in algorithms, and responsible data collection and analysis practices. What are the responsibilities of data scientists and analysts regarding ethical and privacy considerations when conducting data mining? Data scientists and analysts have important responsibilities when it comes to ethical and privacy considerations during data mining. Data privacy. They must ensure that the data they collect and use is obtained legally and that the privacy of individuals is protected. This often involves obtaining informed consent or anonymizing the data. Transparency. Being transparent about data collection, usage, and sharing is crucial. Data scientists should communicate their methods and intentions clearly to stakeholders. Bias and fairness. They need to be aware of potential biases in the data and take steps to mitigate them. This includes addressing issues related to fairness and discrimination. Data security. Protecting data from unauthorized access or breaches is vital. Implementing strong security measures is a fundamental ethical responsibility. Respecting data ownership and usage rights is essential. Data scientists should adhere to data sharing agreements and not misuse data. And without no, respecting data ownership and usage rights is essential. Data scientists should adhere to data sharing agreements and not misuse data. Informed decision making. Presenting data and analysis accurately and without manipulation is key. to avoid misrepresentation of results as an ethical imperative. Regular review, continuously evaluating the ethical implications of data mining and being open to feedback and correction is important. Regulatory compliance, staying current with data protection and privacy laws such as GDPR or CCPA and ensuring compliance with these regulations. Benefit versus harm, assessing the potential benefits of data mining against any potential harms or risks to individuals or society. Striking a balance is crucial. Ethical considerations, engaging in ongoing ethical discussions about the use of data in society and participating in the development of ethical guidelines for this field. In summary, data scientists and analysts must be ethical stewards of the data they work with, respecting privacy, transparency, and fairness, while also staying compliant with relevant laws and regulations. Examine the trade-offs between data utility and privacy preservation in data mining. Balancing data utility and privacy preservation data mining involves several trade-offs. Data anonymization. To protect privacy, data can be anonymized by removing or encrypting personally identifiable information. However, this may reduce the utility of the data for certain analysis. Granularity. Coarse-grained data may preserve privacy better, but it can limit the level of detail available for analysis impacting data utility. This means data files that are so summarized preserve privacy better, but can limit the level of detail. Yeah. Noise addition. Adding noise to the data can protect privacy. It may introduce inaccuracies that reduce the utility of data for accurate analysis. Data perturbation. Perturbing data through techniques like differential privacy can safeguard privacy, but it can distort results and limit the usefulness of the data. Data sampling. Using a subset of the data can balance privacy and utility, but it may not capture the complexity of the original dataset. Trade-offs in model complexity. More complex models can extract more utility from data, but they may also pose a higher risk of overfitting and revealing sensitive information. Risk tolerance. The trade-off between utility and privacy depends on the specific application and the level of risk a particular organization individual is willing to accept. Ultimately, the choice between utility and privacy preservation in data mining depends on the specific goals, context, and regulatory requirements of the project. Striking the right balance is essential to maximize the benefits while protecting individuals' privacy. How can organizations navigate these trade-offs effectively? Navigating the trade-offs between data utility and privacy preservation in data mining is a complex challenge. Here are some strategies organizations can consider. Anonymization. Use techniques like data anonymization to remove or generalize personally identifiable information while retaining the utility of the data for analysis. Differential privacy. Implement differential privacy mechanisms that add noise to the data in a controlled manner to protect individual privacy while still allowing meaningful analysis. Data minimization. Only collect and retain the data that is essential for intended analysis, minimizing the risk to individual privacy. Privacy preserving algorithms. Employ privacy preserving algorithms like homomorphic encryption or secure multi-party computation to perform computations on encrypted data, preserving privacy. Data masking. Use techniques like data masking or tokenization to replace sensitive information with pseudonyms, ensuring that the original data remains private. User consent. Seek explicit user consent for data collection and data mining and allow users to specify their privacy preferences. Data retention policies. Implement data retention policies that define how long data is kept, reducing the risk of long-term privacy breaches. Data access controls. Implement strict access controls and role-based permissions to who can access and analyze the data. Audit trails. Maintain audit trails to track data usage, helping to identify potential privacy violations. Ethical considerations. Consider the ethical implications of data mining and the potential harm it may cause to individuals and ensure that data mining practices align with ethical principles. Be transparent about data collection and mining practices, providing users with clear information about how their data will be used. Regular risk assessment. Continuously assess the risks to privacy and adjust data mining practices accordingly. Regulatory compliance. Ensure compliance with data protection regulations such as GDPR, HIPA, or CCPA, which often provide guidelines on data privacy. Collaboration. Collaborate with privacy experts and data scientists to strike a balance between utility and privacy. Balancing data utility and privacy is an ongoing process. Algorithms should stay informed about evolving privacy techniques and regulations to adapt their data mining practices accordingly. Thank you. That's it from me.